Hello students, how you doing today? This is Mr. Elliott and I'm here to do your evening lesson. What's nice about today's lesson is there's actually not anything new. If you followed today's practice problems okay, I'm not sure you even need today's video lesson. Maybe it'd help to just print out the pages, look at the examples, and see if you really need this lesson or not. The title of this lesson is, let's shrink Elliott here. Today's lesson is point, slope, form, parallel lines, and perpendicular lines. Let me put on a comma here, and the word and. And it should be noted that before you start this lesson, you're going to want to print out a worksheet. This worksheet will either be directly below the video link or two below the video link. Tried to put it one, but anyway, that would be called a 3.2 slopes worksheet. It already has some examples that are pre-written out, so I just thought it'd be nice to just practice them. Now today's lesson does say point, slope, form, and as I look through the answer key, yep, everything's in point, slope, form. So our answers tonight, we're going to go ahead and put them in point, slope, form, and they will match the answer key, unlike yesterday's did. So, example one, let's take a look at this. Find the equation of a line through the points -5, -1, and -15, -7. I actually did an example a lot like this one yesterday. So if you don't need this example to see this example, maybe you want to fast forward to an example that you do need help on. I'm going to do all my work at the bottom half of this worksheet today, so you don't need to actually use a piece of paper out of your notebook if you don't want to. Let's see, number one, I have the point -5, -1, and the point -15, -7. And whenever you have 2 points and you're trying to create a line for them, the first thing you got to do is you got to find that slope. And give you that slope formula in yesterday's lesson. So if you didn't watch yesterday's lesson, now would be a great time to go back and watch it. But in the meantime, I like to go 0.1 minus 0.2 usually. So I have -1 minus -7 divided by -5 minus -15. -1 minus -7, that works out to be +6. -5 minus -15, that's like -5 plus 15, +10. And that simplifies to 3/5. And then next, we're going to go ahead and put this into point slope form. It does not matter which equation or which point you want to plug into your equation. Friendly reminder of what point slope form looks like. Now we're going to plug the slope and one of these points into the equation. Everywhere I see an m, I plug in 3/5. The x stays the same. And if I plug in the -5, -1, well, it says minus here, and the x-coordinate's negative. Negative of a negative, that creates a positive, so +5. And then because this says a plus here, we'll actually do exactly what it says, and it says -1, so I'd put in a -1. What about if I wanted to plug the other point into the equation? Well, you can do that. The only way it would look different is you'd have the other coordinate in there. The slope would still be 3/5, but in this case, because of the -15, I would put a +15, and because of the -7, I'd put a -7 here. Now, how do you know that both of these equations are similar or the same? They don't look like these are, oh, wait a minute, I've made a mistake. 15. These two equations do not look the same. So how do you know that these two equations really are the same, that they're equivalent? Well, we could multiply it out. If you distribute the 3/5, 3/5 times x is 3/5 x, 3/5 times 5 is 3, and in this case I'd get 3/5x, +3, -2, that adds up to 1. On my other equation, distribute the 3/5, 3/5 x, 3/5 times 15 is 9. Wait a minute, is it? 15 divided by 5 is 3. 3 times 3 is 9. Minus 7. Elliot's made a mistake here because he's not getting the exact same equation. I get 3/5 x plus 2. The equations aren't the same. I'm kind of embarrassed right now. What went wrong? Oh, here we go. I had a -1 here, and I made a mistake here, and I wrote it as a -2. Well, I have taught students to cross out that mistake and continue along, just redo it down below. 3/5 times x, 3/5 x, plus 3, and then not minus 2, but minus 1. And 3 minus 1 is 2, and I end up with 3/5 x plus 2. Hey, the two equations do match now. So that's just me pointing out that no matter whether you want to plug the first point into your point-slope form or the second point into your point-slope form, you will get the exact same slope-intercept answer at the end. So the two equations are equivalent. But either way, for number 1, either one of these two answers would be 100% acceptable. All right, let's get into number 2, or I guess on the worksheet, it's number 3. And number 3 is a problem just like I did in my lesson yesterday. If you are given a graph, what are those equations? I don't have any instructions on there. Well, I'll continue with these instructions here to find the equation. Now, because I have two lines, I need to label them as being y1 and y2. I'm going to do y1 first. They don't give me any points on the graph, so I need to find some points, some happy points, where the graph goes through a good point. And I have a point right here at 0, -2, and I have another point down here at 1, 2, 3, 1, 2, 3, 4, 5, 6, so 3, -6. Well, if I did what I did yesterday, I go over 3, down 4, and it is a downhill graph, and this is y1, so I'd have y1 equals downhill graph, so -3/4, and then plugging this point 3, -6 in for point slope, x minus 3 minus 6. I could have used the point 0, -2, but I had physically written this coordinate out, so I chose to use that one. And that's my y1. y2. Same thing. I first need to find a couple coordinates that the graph goes through that are I'd call happy points. I have a happy point right here, one that goes through a nice intersection. I have another one up here, and this coordinate right here is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So I went up 3 over 4, and it's an uphill graph. So instead of being -3/4 like this one, wait a minute, Elliot made a mistake up here. It's rise over run for y1. So because it's rise over run, it would be 4/3. I did have the negative part right, but it would be -4/3. So I'm just gonna write that in very dark. Sorry students. Elliot does make mistakes every once in a while. Back to the problem. If I look at this other graph, rise of 3, a run of 4, so it's +3/4. And then if I plug this point in there, it would be x minus 4 plus 6. And those would be the equations of these two lines. And if we talked about what we talked about yesterday, I have one slope is -4/3. Another slope is +3/4. Those are negative reciprocals. That means that those two lines are perpendicular. Neat. All right, let's take a look at number 8. Now, what you could do is if you find 8 to be a nice looking problem, pause this video, try out number 8 on your own, and then watch Elliot solve it and see if you use the same techniques. In this one, I have a line parallel to this 5x minus 2y equals 20, but in order to find the slope, I need this equation to be solved equal for y. So I'm first going to subtract 5x from both sides, giving me negative 2y equals negative 5x plus 20. Divide both sides by this negative 2, and y equals, 5 and 2 don't divide evenly, but they're both negative, so that would become positive 5 over 2x. And positive 20 divided by negative 2 is negative 10. So I have positive 5 over 2x minus 10. So the slope of this line right here, of this first equation, is 5 over 2. Now, I want the equation of a line parallel to that one. And as we've talked about, parallel means that the slopes are equal. Don't use the word same, use the word equal. The two slopes are equal. So if the slope of our first line is 5 over 2, the slope of our second line must also be 5 over 2 because of the whole parallel. And then I also needed to pass through the point negative 6, negative 13. So then I simply put that point into this equation, minus x1, that becomes plus 6, and then the plus y1, so I'd put this minus 13. And that's number 8. Moving on to number 9, same thing. Pause the video, try out number 9 on your own, and then watch Elliot solve it. In this case, I need perpendicular to 4x plus 3y equals 24. Same thing as the previous problem. I first need to solve both equations for y. I get 3y equals negative 4x plus 24. Divide both sides by the 3. And I get y equals negative 4 over 3x plus 8. Now, perpendicular. We talked yesterday that perpendicular means negative reciprocals. So if the slope of the first line is negative 4 over 3, in my answer, using the same m, x minus x1 plus y1, the negative reciprocal of negative 4 over 3 is positive 3 over 4. And then it needs to pass through the point negative 8, negative 10, it says in the instructions. So I plug this point into my equation here. So I have minus x1, but the x1 is negative. So I put plus 8. And I have a plus y1, but this is negative, so minus 10. And that's our point slope for a perpendicular line. Nice. Well, this leaves one example, number 14. Let me get a fresh piece of paper. And 14 is a good problem because this shows a little bit of deeper understanding of slope, I would say. And in 14, they give you these 2 points. The first point is negative 2k, and the second point is 5, 3k minus 4. And it tells us that the slope of these two lines is 8. So if we take these coordinates, if we take these two coordinates and plug them into our slope formula, we have 3k minus 4 minus k all over 5 minus negative 2, and this must be equal to 8 because that's what the slope is. Now let's solve this. 3k minus k, that's 2k. So 2k minus 4, 5 minus negative 2, that's 7, equals 8. People don't like fractions, and you can always get rid of fractions using multiplying. Because the denominator is 7, you can multiply both sides of this equation by 7. 7's cancel out. You get 2k minus 4 equals 8 times 7, which is, of course, 56. Add 4 to both sides. 2k equals 60. Divide both sides by that 2. K ends up equaling 30. And that's what we're trying to do in this problem. Find the value of k. And that is our value of k. Okay, so this was just using some main ideas that we talked about yesterday and applying them to some problems. If you did that slope worksheet for practice yesterday, this lesson probably went pretty smoothly for you because it was the same general ideas as those problems. And have yourself a great Thursday night, and I will see you tomorrow on Friday. and when I have some more practice problems for you. And like yesterday, if you want to get a head start on those practice problems, you can find them directly below the link to this video. Now let's make Mr. Elliott big again so that we can say, have a great night, everybody. See you tomorrow. Bye-bye.